Now it's time to have a look how loop 4 works for an example which sounds more like something real life and not just adding numbers which don't make much sense to us. So let's have a look at this case. So Josh has bought a car, new one, and he decides to keep it for 20 years. And in this case, he wants to take really good care of it, so he will service it every year according to the plan. So initially he's told that usual annual service cost would be $240. And assuming that Josh follows the service plan, how much will he have spent on servicing cost altogether after 20 years? So the first point is simple because we could just multiply the $240 by 20 and that gives us the answer. But if we go to point B, then we get more information that, or we ask what would be the amount if every third service would cost more, and that would be $320. So we look at year 1 and 2, he pays $240, then third year $320, and then again year 4 and 5, $240, and then year 6, $320 again. So in this case already, it is much easier to rather write a loop than to start thinking. So how many of those 20 years will be the more expensive ones and how many are the normal? So let's leave out point A because that one was straightforward. Or actually we can use point A as base and then we will extend it to create point B, because actually point A can also be written in a loop. It's a silly one, but it's a good starting point for the second part of the task. So the base service cost will be $240. The overall spending initially is nothing when he buys the car, but of course after years start going, he will be spending more money. Then we know the years, that it's supposed to be altogether 20. And I think for the point 8, this is all the information that we need. So we will have a for loop which will go through those years. I will call it y, the index which visits all the years, and we know that he will be servicing every year from the first one, or from when first year has passed, he has to do the first service up to the 20 years ahead. And then what happens is that his service spending will be growing. So it will be what it was before, but plus this extra service cost. So this is the simple case. Now we know that if we did it manually, we know, or I mean in the straightforward way, so we know 20 years of paying $240, we should get 4,800 altogether. So now let's run our code and see if this calculation is the same what we get from the loop, and yes, that's the case. So this is the point A. But now in point B, remember, every third year was supposed to be more expensive. So now it means that this what we add here will not be always S. It will be changing. Sometimes it will be this initial S and sometimes it will be bigger. So I will modify this code so that I'll actually make S1 and S2 to mark the two different amounts. And now it means that we will need some kind of condition here based on which we will be deciding which one we are adding. And if it's a condition, it normally means we have to use if-else statement. Now, how do we check that it's every third year? We know that y is the variable that is tracing our years. So it goes 1, 2, 3, 4, 5, 6, 7, and so on up to 20. Every third means 3, 6, 9, 12, and so on. And we could try and use some smart way to just check if the y value we are looking at the moment is divisible by 3 or not. And I'll give you a hint that there is a couple of functions in Matlab that can help with that, and one, for instance, is rem. So rem is, it checks what remains from dividing one number by the other. So if a number, any number is divisible by 3, it means that when we divide it, nothing remains. Like there is no fraction left. So it's like a whole division. 6 divided by 3 is 2, no fractions left. For instance, 8 divided by 3 is 2 and 2/3 left. So there is something remaining. So that means, for instance, here, if I say rem 6 and 3, I should see 0, because no fraction remains. But if I do rem 8, 3, I will see, maybe let's take 11, for instance, then I will see 2, because the result is 3 as an integer result, but there is also 2/3 left from that division that is not a whole number. So the answer to this is 2. So now what does it mean for us? It means that the specific year will be every third year if it's divisible by 3. So I will build my if construct here, and I will say if that particular year, so y, because this is the variable which keeps changing the years for us, if this one divided by 3, if what remains from that division equals 0, which means it is divisible, so it means this is the more expensive year, and our service spending will increase by this higher amount. And otherwise, so in any other year, it will be the cheaper one. So I add this, and I change it to S1. So I don't have to write anything else into else other than just the job to do, because this really means that any other year, all the divisible by 3 should be a higher price, and the non-divisible should be, which means all the other ones are the lower price. So this should be now our calculation. Now we think quickly, just for a manual check. 20 years is relatively small, so within 20 years there will be 6 more expensive checks, because it's 3, 6, 9, 12, 15, 18 years. So 6 times 320, and then all the other years. So if 6 are more expensive, so 14 left are with the cheaper price. So the result we should get is 5,280. So let's check if our loop gives us the same, and yes, that's the case, 5,280. So now we can see that it is also possible to embed loops or if-else statements inside loops, and there could be multiple of them. Okay, so now let's check what is the last part of this task. Now we hear that additionally to point B, so the one we just wrote, every 8 years the car should have its transmission belt changed at an additional cost of $800 per change. how much will the car's servicing cost amount to altogether, assuming that Josh keeps it for 25 years from the day of purchase. So we have yet another cost, and that means that let's maybe copy, let's call this make this one section, and then I'll copy this as a base. But then we will need some extra modifications. So what do we do now? Well, this transmission belt change is an extra cost on top of the servicing. So in that year, for instance, in year 8, he will have to pay $240 plus extra 800. In year 16, it will be the same because it's not divisible by 3. But for instance, in year 24, you would actually have to pay $320 and the $800. So that means that we will need an extra check on that divisibility also for 8. And it could be done in two ways. We could either have a number of combinations in here, so that we combine divisibility by 3 with divisibility by 8. But we could just have an extra embedded if inside, so that in case we hit a year divisible by 8, whether it's also divisible by 3 or not, then it happens in here. So that's the way I will do it. So I'll add here transmission cost is 800, and now we're supposed to do it for 25 years. So what I will do is now that this base check for every third year remains, but additionally now under this case, I will say that, or actually, yeah, it doesn't have to be done twice, because this will decide on the service cost, but now just as a completely additional separate check, I will now say that in case that year is also divisible by 8, so what remains from that division is 0, then I will yet increase the spending on the service by the transmission cost. Actually, that's the more straightforward. We could have added this as an extra. I'll put it here, but comment. So we could have had it placed twice within the two conditions without this one. But then the code looks less neat. So it is actually much better not to have them here and have it done in here. So because anyway, if we hit that year, that it's 8, 16, 24, then it will have to be added anyway to whichever case we have here. So now maybe let's call this spending 2. I will now remove those commented ones and spend 2 in here as well. Okay, so let's run and let's see what would be the answer. Yeah, it's the second one. So now it's 9,040. So you can see, using loops, it's not only about some weird formulas to add things up. It's actually to use it in some calculation cases that are real life.